So what is a tree? In the real world, they would look like this. But in data structure, they would look like this. Roots up, leaves down. Yep, upside down. So here we have an example of a binary tree. In a tree, we have nodes and edges. The nodes, which are the circles which we can refer to as the leaves, and the real world trees, store the data. In this case of a binary tree, numbers. And the edges, which are the lines that connect the nodes, which we can refer as the branches holding the leaves in the real world trees. They connect the nodes and put them in their respective places depending on the value they have. So here we have another example of a binary tree. I'll explain how it works or how you put and arrange the values in it. So let's say you have 11 as your first data. It will put it on the top of the binary tree there, making it the root. And let's say you insert another data, which is 19. And 19 is greater than 11. So you put 19 on the right branch of 11. Anything greater will be on the right, and anything less will be on the left. Okay, now we have 43. And 43 is greater than 11. So we put it on the right branch of 11. But since 19 is already there, we'll have to see if 43 is greater or less than 19. If it is greater, so we put it on the right branch of 19. Okay, so now let's put in 31. From the top, 31 is greater than 11, so we move to the right. Then we have 19. 31 is greater than 19, so we move to the right again. And now we have 43. And 31 is less than 43, so we put 31 on the left branch of 43, which is there. So from there on, I think you can see why each node is placed in their respective locations. So let's move to binary search tree. So I will show a code later and this would be the output. The values printed as outputs are the values that are inserted in the tree and are already arranged as to the rule of a binary tree. The values are printed by left to right order and by level. So here we have a method called binary search tree insert, with a parameter int value is made wherein we initialize the value into the node. In this method, we will first check if the root is empty or not. If it is empty, we initialize the value of node to the root and will be set to return the value. Then we continue the process in which we call another method that will insert the values in our tree, the insertRect, holding two values, the root and the node. So here we have insertRect. Its job is to check if the last node is greater than the node that's being traversed. Then it will check if the node is null or not. If null, it will return the left node to the root. And if not, it will make the left node the latest one. But if the right is greater than the node value, it will check if it is empty, then it will make it the latest root. So display BFP. The height of the tree should be first identified and the height will serve as the restriction of the loop. The loop will be used to traverse each level of the tree. For example, at the first loop, level 0 is visited and nodes existing at level 0 will be displayed. And lastly, display BFT value. It will check if the current root is null. If null, it will return. If the level is equal to 0, then it will print the current root. But if the level is greater than 0, then it will print the left root. So here is my node to call out and perform my methods. And here is my implementation to put in values. So again, here's the output of the code. The values already arranged as to the rules of a binary tree printed from left to right and by level. So my name is Josenilo Pilapio Jr. from BSIT 2A, hoping for a chance to pass. Thank you, sir. God bless. Take care.